Hi and welcome to another video for Year 9 Additional Maths on the chapter series. So today you are going to deal with the binomial theorem for binomial expansion. So this one is the real formula that you have to use in your exam or in your exercise. So here use binomial theorem to find the expansion of a to the power of a plus b to the power of n for any positive integer n. So this one, there is a specific symbol that you have to use to expand binomial theorem. So this one will be in your calculator. I will show it later. And also some of the terms that you will do, it requires you to understand factorials. But for this topic, for this examples, for this video, you will not really use this first, but let's have a look at the easier examples first. So here, let's have a look. Okay, so Pascal's triangles can be used to expand a plus b to the power of n for any positive integer n. So as you have seen previously, you will have to use Pascal triangle, but however, if n is too large, so here there's an alternative that we can use. So what button can we use? Or in your calculator, we can use combinations to expand binomial expressions more quickly. So here, if you have your calculator, you press shift and then press the button here. So this button, we call it combination. So for example, if you are tapping down 5 combination 0, so I will call it combination for this video. So here 5, shift, and then you go to this button, it will, there is a C will appear. So 5C0 will give you a 1. And then 5C1 will give you a 5. So here, just write down 5 over here. 5 combination of 5C2 will give you a 10. And then 5C3 will give you another 10. And 5C4, just use okay, so here this is a 5 and 5C5 is a 1. So here, if you notice that this numbers is actually the 5th row of Pascal's triangle, isn't it? So here, in a way, you don't have to memorize the Pascal's triangle. It's enough by using calculator to find out the expansion of binomial term. So binomial term, so as we have covered last time, it is a term with it is an expression with two terms. For example, a plus b, and then there's a power outside. So this one, if you see this one, you just have to replace the coefficient in the Pascal triangle with the combination button over here. So you can see here, this is the previous lesson. As you can see, as per usual, A will decrease in their power, and then the power of B will increase. So here, in general, this one, if you have a power of n, so the number before the combination will be n. So here, this is the general formula for binomial expansion, and nc0 is a 1, and ncn is also a 1. So this is the formula that you will see in the formula booklet or the formula in the first page of your exam paper. So here, this is the general, and this is the notation for combination. So N1 in a column bracket over here means NC1, NC2, NC3, and so on. So this formula above is known as the binomial theorem. So let's begin with using the binomial theorem to find the expansion of this one. So here, identify first what is your A, which is a 3, and then the B is a positive 4x. And the power n is 5 over here. So here, let's proceed with the expansion. So, as you can see here in the formula, you begin with a to the power of n. So here, your a is a 3, and the power n is to the power of 5. And then for the next term, you just have to use the combination. So here n C1, so your n is a 5, C1. So 5 C1, and then your A, which is 3, will be to the power of what? So here your power for A will decrease. So this is power 4. Okay, I can double check here in the formula over here, n minus 1. So this is decreasing. But here you can see B is increasing. B to the power 1, 2, 3, and so on. So here, let's continue. 5 C2. Oops, sorry. Here, your B will be here also. So your B is for X. So here the B will be B to the power 1. So just write it down. And then the next term will have 5C2. And your A is 3. And it will be to the power of 3, which is decreasing from 5, 4, and then here 3. And as your B over here, multiply by B, so for x power 1, it will increase to 4x to the power of 2. And then the next term, 5C3. So next to the 5C3 is an A. A will have the power of, it will decrease from 3 into 2. And B over here is for x. It will have a power of 3. So here, let's double check first. So the power of A will decrease and the power of B will increase. So here, let's move to the next term, 5C4. So here, you have an A over here. Your A will be power 1, and your B, which is for x, will be to the power of 4. And last but not least here, the final term, 5C5 is a 1, but you don't need to write it down. So, and A, which is 3 to the power of 0, it will be 1, but all you have left is for x, everything to the power of 5. So this is the complete use of the binomial formula or binomial theorem over here. So let's figure out all the numbers and simplify if necessary. So here, 3 to the power of 5 is 243. And then here, my biggest advice for all the students, I usually will figure out what are the numbers before I multiply them all together. So 5C1 is a 5. And I will still put the brackets in, but I will evaluate them individually. So here 3 to the power 4 is 3 to the power 4 is an 81. So 5 times 81. And 4x power 1, it's still 4x. Alright, so that's for the second term. The next term, 5C2. 5C2. So 5C2 is a 10. So plus 10. And 3 to the power of 3 is 27. And 4x to the power of square is 16x squared. Alright, and then the next term, 5C3 is a 10. So here plus 10 and 3 squared is a 9 and 4x cubed, so let me double check, 4x 4 to the power of cube will be 64. So this is 64x cubed. And the next term over here, let's put it just down here. 5C4, I predict it will be another 5. Yes, it is another 5. And then 3 to the power of 3. 4x to the power of 4 is 4 to the power of 4 is 256. X to the power of 4 plus, so 4 to the power of 5, it will be 1024. 1024 x to the power of 5. So let me double check this one first. Here, and then 5, 3, 2, 5, 6, x power 4, and 1000. Alright, so here this is the next step. So just have to simplify by multiplying the numbers in the terms. So for the first one, 5 times 81 times 4, it will be 1620. So 1620 x, and then here for this one, I just write down the answer straight away. Right, and you can double check it after you have watched the video over here. So here, this one is for x cubed, and for the x to the power 4, this is the number, the coefficient, and last but not least, 1024 x to the power of 5. So this is the final answer after you expand 3 plus 4x, everything to the power of 5. Right, so let's move on to the next example. Okay, the next example here, it's finding the coefficient of x to the power of 20, specifically in this particular expansion of 2 minus x to the power of 25. So here you can see there's a lot of power over here, n, and the coefficient that you're looking for is x to the power of 20. So over here, actually you can use this to find a specific term. So this formula, the NCR, a to the power of n minus r, b to the power of r, is actually within your formula also, which is over here. So this is kind of like a general formula for the term in the binomial expansion, a specific term. So for example, here you are looking for the coefficient of x to the power of 20. So you are looking for the term which has x to the power of 20. So for this case, since your a is a 2 and your b is a negative x and your n is a 25. So for this case, the power of x, the negative x over here, should be a 20. So b to the power of r, so r must be a 20. So here, r must be equals to 20 because it is on b. So here, you just have to write down and use this formula to find the term that contains x to the power of 20. So the term with x to the power of 20 is using this formula, the n is 25, c, and your r is 20. So 25c 20, your a is a 2, n minus r. So n minus r is 25 minus 20. So 25 minus 20 is a 5, okay, but just write it down there. And your b is negative x to the power of 20. So over here, there you have it. You just have to find each number first, which is 25c 20, which is 53,130. So 53,130. And 2 to the power of 5 is a 32. And negative x to the power of 20 is going to be positive x to the power of 20. So here, if I multiply 53,130 times 32, will give you a million. So 1,700,160 x to the power of 20. So there we have it. Therefore, coefficient of x to the power of 20 is going to be 1,700,160. So there we have it. So this is when you have to find a specific term which you can use NCR, a to the power of n minus r, b to the power of r. Alright, so let's move on to the last example. So the last example for this one, this is find in ascending powers of x the first 4 terms. So here, there's a specific term that you have to find in the expansion of 1 plus 2x to the power of 6. So over here, although you have an index of 6 in which you will have 6 terms at least, but you will have to find only the first 4 terms. And once you get the first 4 terms, you will use it to answer part B, which is find the coefficient of x cubed in the expansions of 1 minus x to the power of 3, and there's also 1 plus 2x to the power of 6. So A and B are very, very related. So let's begin. So for this question, your A is 1 and your B is 2x positive. So here you have also the power of 6. So let's begin. So you begin with A to the power of n, which is 1 to the power of 6, which is always 1, plus the second term, which is 6c1. Okay, there's a coefficient, which is using combination over here. And there's also 1. And the power of 6 will become the power of 1 in the second term. And as for B, which is 2x, it will be a power of 1. So you have the first, second term. And the next term, the third term, is 6c2. So here 62, and 1 will be 1 to the power of 4, which is always 1, but just already done. And then 2x will be to the power of 2. And then the fourth term, okay, so this is going to be your last term to be written, 6c3, and there's a 1 as your A, 1 to the power of 3, which is decreasing from 4, and also B, which is 2x, will be written as power of 3. So the next few terms, you don't need to write it down because it is not required. So I'll just write down a continuation of dot dot dot. So let's expand this one properly. So here 1 to the power of 6 is 1. 6c1 is a 6. 1 to the power of 5. Okay, every term with power of 1 will be always 1. And 2x to the power of 1 is 2x. And the next term is 6c2 is a 15. Okay, double check here. 6c2 is a 15. And 1 to the power of 4 is 1. 2x to the power of 2 is 4x squared. And the next term is 6c3 will be 20. So 20 and then times 1, and 2x cubed is 8x cubed. So here, there you have it. The final expansion for this one is 1 plus 6 times 2x is 12x. 15 times 4x squared is 60x squared. And 20 times 8 to the power of 3 is 160x cubed. So this is your required answer for part A. So let's move on to part B. So for part B, it is regarding the expansion of 1 minus x to the power of 3 and also 1 plus 2x to the power of 6. And here, this one, 1 plus 2x to the power of 6 is from your previous part of the question, which is 1 plus 12x plus 60x squared plus 160x cubed. So you just have to copy down this one here. So this one, your real question is 1 minus x to the power of 3, and there's a bracket off over this one. You just copy down this one, 1 plus 12x plus 60x squared plus 160x cubed. So this one, you have to do a further expansion, but here it says specifically to find the coefficient of x cubed. So you just need to find the terms that contain x cubed. So here, when you do the expansion, So here 1, you just have to multiply with this term that contains x cubed, which is 160. And x over 3, negative x over 3 will be multiplied with 60x squared. So you will have the term over here, 1 times 160x cubed, and also minus x over 3 times positive 60 x squared. So just this one, just have to be careful here with the expansion. So 1 times 160 x cubed, it's still 160 x cubed, and x over 3 times 60 x squared is going to be minus 20 x cubed. So here 160 minus 20 x cubed is 140 x cubed. So this is the term that contains 140 x cubed. So therefore, coefficient of x cubed is going to be 140. So this is your final answer for part B. So there we have it. If you have a look here, the expansion using the binomial theorem. So with that, that's the end of this video. I hope that it will help you in taking your notes. Okay, so with that, thank you very much and see you next time.